Hey everyone, welcome to the Scientific Edge. I'm Tony, and today we've got something special for you. This is a mega video compilation of some of our shorts packed into one long video. From exploring the mysteries of quantum mechanics and the secrets of animal intelligence to diving into the potential of AI and beyond, we've covered a lot of intriguing and thought-provoking topics. So sit back, relax, and enjoy as we journey through the fascinating world of science. Don't forget to like, subscribe, and hit the bell icon to stay updated with all our latest content. Stay curious.
And so if this has a rhythm to it, there is nothing in the solar system that has a 20 million year rhythm. So someone suggested maybe the sun has a really eccentric, as in its orbit, it's in a binary star system where there's another star that plunges in through the solar system, coming through the Kuiper belt, and then goes back out in this dance with the sun. So we wouldn't have seen it in our civilization, because this is all right. But when it does that, it disrupts the Kuiper belt gravitationally. And if you do that, you will send a rain of comets down, a higher than average rate of comets down into the inner solar system, and then you could render many life forms extinct on Earth, just the way we lost the dinosaurs from an asteroid. So, and they even gave a name for it. They called it Nemesis. And so if this has a rhythm to it, there is nothing in the solar system that has a 20 million year rhythm. So someone suggested maybe the sun has a really eccentric, as in its orbit, it's in a binary star system where there's another star that plunges in through the solar system, coming through the Kuiper belt, and then goes back out in this dance with the sun. So we wouldn't have seen it in our civilization, because this is all right. But when it does that, it disrupts the Kuiper belt gravitationally. And if you do that, you will send a rain of comets down, a higher than average rate of comets down into the inner solar system, and then you could render many life forms extinct on Earth, just the way we lost the dinosaurs from an asteroid. So, and they even gave a name for it. They called it Nemesis. We're looking at Neptune's orbit, and it's not following Newton's laws. And this is odd. Well, we've been down that road before. Uranus didn't follow Newton's laws. We proposed another planet and we found it. So Neptune's not following all the laws of gravity that from all the other planets in the sun. There must be another planet out there, a planet X. Let's look for it. So light is just bouncing around within the universe. In fact, a lot of visible light is doing this. Then the universe expands and cools. The electrons combine with the atoms. All of a sudden, the beam of light is no longer batted to and fro by these free electrons. And you reach a point where the universe clears, and it becomes transparent to the passage of light. In that moment, all the light that was contained in that fireball now moves free across the universe. That light, for the last 14 billion years, has been expanding with the expanding universe, and the energy of the visible light is now microwaves. You point a microwave telescope in any direction, it is bathed in microwaves from that event.
Whoa.
Emergence is a property, a fascinating property of an organism that is not derivable from any of its parts when you look at it. So, for example, you can study a bird, and you can know everything there is about a bird, but you would not have necessarily, I don't think, been able to predict that birds flock together.
Oh.
So the flocking is emergence. That's an emergent
What I'm talking
phenomenon.
about is something emerging.
Information would be cheap.
Right.
And so I'm not one to just take what's going on now and extrapolate it and say everyone is going to be living that differently, because other things come in from the side that you don't anticipate. And when they come in from the side, it is not an extrapolation of what you're doing now. It is something you didn't even imagine, because an innovative, creative person looks to the left, looks to the right, and says, I can combine these into something that's completely new, that no one even imagined. What is a new idea? You might even call it the definition of genius. It's you see what everyone else sees, but you think what no one else has thought. But now you want to make sure, but add to that, maybe you are so diverse in what you expose yourself to that you see more than what other people see. And when you see more, you have the capacity to make connections that might not have previously been imagined, either by you or by anybody else. There was a neuroscientist, well, a brain scientist, who, because you can't do experiments on human brains, that's not ethical, and all right, all you can do is wait till someone gets an accident, and so there's a nail gun that damages this part of the brain. Oh, you lost your language. Damage of this part. Oh, you lost your short-term memory. Oh, you lost your long-term memory. And so you assemble the bits of what the brain is doing by people who were injured. This is a very slow, clumsy process, but that's all you've got. The person who had an article said, the brain is so complex. Today, we only know what 10% of it is used for.
And that got...
Overnight, that became we only use 10% of our brain. And that became the mantra of school teachers getting children to rise to their potential. And there was no force operating against that coming into our culture. And he says, I want to find planet X because something's perturbing Neptune. So he sets out looking for it, and he doesn't find it. Then he hires Clyde Tombaugh. And he dies, so he doesn't see the results of this. Clyde Tombaugh, he said, I can't find it either. I will just systematically search everywhere. Because if you think something's affecting you gravitationally, you ought to have some idea where it is to be tugging on you in that way. All right? That's not some kind of weird, it's like you're moving differently. Where must the thing be to tug on you so that you're moving in that way? Right. No one could find such a planet X. So Clyde Tombaugh said, it's got to be out there somewhere. I will systematically image the entire sky, all right? And you got to do it on multiple nights because if something's moving, you'd see it change from one picture to the next. He does this, discovers Pluto. Just imagine that, okay? Maybe they have what we would call an animal, but their entire skin photosynthesizes, okay? So all living creatures on that planet consume sunlight from their home star, okay? And so they say, I want to explore the galaxy. And so they build a spaceship and they come to Earth. And what do they see? Humans and other animals killing to survive. Inventing means of mass murder of fellow other life forms on their planet just to survive. They would consider us astonishingly, inexcusably, bewilderingly barbaric for having done so. The line that identifies a 16th of an inch itself has a width. So where are you within the width of the line that you're using to report how tall you are?
So we're giving rough measurements.
Anytime you give a measurement of something, it can never be exact.
But you get an understanding of it.
But now we take quantum physics, which is the science of the small, and add it to Einstein's general relativity, the science of the large. Now, why would you do that? Because at the beginning of the universe, the large is small. So think about this. We have general relativity, which gives us black holes and all the rest of this. That applies to big macroscopic things. I'm good with that. No problem. Quantum physics refers to atomic things primarily and molecules and how they behave. Okay, so now with regard to, another scenario, which got folded into yours, is that our orbit around the galaxy is not sort of a straight circle, a clean circle. We actually wave in and out of the plane of the galaxy. All right, like if you imagine sort of Nessie, Loch Ness Monster doing that, okay? So to imagine that, so our orbit, our entire solar system is dipping up and out and through. So another suggestion was, in fact, I think there was an entire book on this. Forgive me for not remembering the name. It suggested that the entire solar system, as it passes through the plane of the galaxy, that disrupts the Kuiper Belt as well. And that lodges, it's basically the Kuiper Belt says lobbing comets bed down into into the inner solar system. And so you can look for that in the extinction record as well.
I think that we are at a level where we're so intellectual that we're almost too intellectual. So it's almost like we can only think about things in this scale. Like people see in a certain frequency, they can only see certain lights, but like dogs can hear sounds we can't hear. Others,
Right.
so it's just like that. It's like our intellect is like this, and we can figure out all, but
Because we exist within the context of our culture.
because we've fallen in love with this.
Right. Our mind.
But there's also this, and
The heart.
your spirit. That's what figured out the Tao Te Ching.
I mean, imagine if you got to a place where you had a self-contained solar system that's completely controlled by these intelligent beings, but that's immune to all of the hazards.
What
of
if we're
space.
in that?
We might be.
That's the simulation.
We might be. We might be. We might
And
be.
Thanos is like,
A Type 2 civilization, one that can directly harvest the energy of its star using a Dyson sphere or something similar.
so it like is solar powered basically.
Well, I don't know what the f it is. I mean, I think it's totally theoretical. There's no real versions of them that are out there. But the idea is that if technological proficiency and innovation continues at the level that it is now for millions of years, what does it get to?
Yeah.
So once a time machine is invented, then everything from that time machine is invented forward becomes a completely different way of using time. Because time now is nonlinear.
Yeah.
Time now,
It's this
anyone can go.
malleable
So
thing.
everything happens all at once.
Yeah.
So people from the future will be traveling back to the moment where the first time machine is invented. So everything will change instantly.
Yeah.
Because if you're gonna invent a time machine and you live 1,000,000 years in the future, assuming that humans even exist, if a time machine gets invented, I mean, we might become obsolete almost instantaneously. But if you were a live human being 1,000,000 years after the time machine is invented, you would want to go back to the moment the thing was made.
And it just tells me, I mean, in some ways, how necessary sleep must be. If that's the lengths that the brain will go to get that which it's been missing,
Yeah.
just shows you why, it took Mother Nature 3.6 million years to put this thing called an 8-hour sleep necessity in place. And we've come along, and within the space of 100 years, we've lopped off almost 20% of that, if you look at the data.
Wow. Really?
Yeah.
And so many people take pride in that too. I don't need 8 hours sleep. I got 3. I'm good. Ready to go. Kick ass and dominate the world.
Yeah.
Yeah.
It's the sort of like sleep machismo sort of attitude.
There is a lot of that, right?
Yeah. And
Not me, baby. I like sleep.
Well, I mean, and you'd be glad to know that then, men who sleep 5 to 6 hours a night will have a level of testosterone which is that of someone 10 years their senior. So a lack of sleep will age you by a decade in terms of that critical aspect of wellness, virility, muscle strength.
To the average person, if they think about space, they think about intelligent life.
Yeah.
That is far more interesting to them than the fact that there's black holes out there that are devouring planets.
Yeah.
That are
Yeah.
sucking stars into its event horizon.
Yeah.
This infinite point of density that we can't even really begin to imagine with our own little brains.
Yeah, yeah, and the fact that all this arose without a guiding intelligence.
Yeah.
That there are black holes and there are active galactic nuclei and there are black holes slamming into each other, creating gravitational waves that we can actually detect. We're fundamentally storytellers. That's what human beings are. Now, there's the reductionist story that physicists are well equipped to talk about with particles and laws of physics. On top of that, you've got the chemist story, the complex molecules. You've got the biologist story that begins to talk about cells and life. You got the psychological story, the neurophysiological story that brings in mind and consciousness. And within that, you then have all of the activities that conscious beings undertake, which includes religion and includes telling other kinds of stories and includes creative expression. You need them all. And to sort of say that the scientific account is the only account by which you're ever going to gain true qualities of the world is a very, in my view, limited description of what truth is.
Yes.
I mean, for instance, we have agency detection systems in our brain where we look around the world and we tend to assign agency to things that happen. That's useful, right?
Yeah.
Because, if you mistake a windblown branch for a jaguar, yeah, it's fine. You thought it was jaguar, but it's just a branch. But if the reverse happens, you think it was a jaguar and you think it's a windblown branch, you're going to get eaten.
Yeah.
So we tend to over-endow agency into the world. There is evolutionary value to that. So when the wind blows, we tend to think there's a mind up there. When the river gurgles, we tend to think that there's a mind in there.
Yeah.
And this is sort of the seed for the kinds of perspectives that you'll find in many of the world's religions. So there's natural course of events that can lead to the arising of the institution, or at least the ideas behind the institution of religion. And for students that have never encountered that idea before, it can really shake things up, and I think in a very valuable way.
Research on animal intelligence not only enhances our understanding of the natural world, but also has practical applications. It can inform conservation efforts, improve animal welfare, and even inspire new technologies. For example, studying the social structures of elephants can help in developing better conservation strategies, while understanding the navigation skills of migratory birds can improve our knowledge of animal migration patterns. In conclusion, the intelligence and consciousness of animals are remarkable and diverse. Dolphins, chimps, elephants, and crows demonstrate cognitive abilities that challenge our understanding of what it means to be intelligent. Now let's compare the intelligence of these animals to humans. While animals like dolphins, chimps, elephants, and crows exhibit impressive cognitive abilities, there are key differences in how they and humans process information and solve problems. Humans have larger prefrontal cortices, which are associated with complex decision-making, planning, and abstract thinking. Our ability to use language, create art, and develop advanced technologies sets us apart. However, the cognitive abilities of these animals show that intelligence is not unique to humans and can manifest in diverse and fascinating ways. Humans and these intelligent animals share some cognitive skills, such as problem-solving and social learning, but the way we apply these skills can differ. Dolphins are often considered one of the most intelligent species on Earth. They exhibit complex social behaviors, use sophisticated communication methods, and have shown problem-solving skills that rival those of primates. Dolphins have large brains relative to their body size, and their cerebral cortex, the part of the brain involved in higher-order functions, is highly developed. They can recognize themselves in mirrors, indicating self-awareness, and even create unique vocalizations that function like names. Research has shown that dolphins can understand abstract concepts, such as numerosity, and they can cooperate to solve tasks that require teamwork. Chimpanzees share about 98% of their DNA with humans, and their cognitive abilities reflect this close genetic relationship. They can solve puzzles, exhibit empathy, and plan for the future, all signs of advanced intelligence. In the wild, chimps have been observed using sticks to fish for termites, stones to crack open nuts, and even leaves as sponges to soak up drinking water. These behaviors demonstrate their ability to learn from their environment and innovate solutions to problems.
Initially, it was entirely found because areas of the rainforest had been cleared. Economic interests said, we want to make a cattle ranch here, or we want to make a soybean farm here, so we're just going to clear the rainforest. In the process of clearing the rainforest, they start discovering these earthworks that had previously been completely overgrown by the jungle. Then the next step was to say, what could we do to find out more about this? Obviously, they don't want to destroy more jungle, and luckily we have a technology which is LiDAR, as I mentioned, which uses radar. And using LiDAR, they've been able to identify many more of these sites, and then to get to the sites without destroying the jungle, and to begin excavations on them, and to find that they go back, in the cases of the ones that have been explored so far, at least 3,000 years. This is an intriguing development, completely unexplained in our understanding of the Amazon. And what it suggests is a heritage of extremely ancient knowledge. LiDAR technology is being employed in the Amazon. It's non-destructive. You can see what's under the trees.
What is LiDAR?
Light imaging and detective radar. They bounce laser beams down into the jungle. There's a whole pattern of them. You need helicopters, and but it doesn't damage the rainforest. And you can strip away and see what's there. If this isn't too much of a diversion, let me give you the example of Guatemala. Guatemala is a small country. If I remember correctly, it's not much more than 100,000 square kilometers in size. It is filled with intriguing Mayan ruins. Everybody has heard of Tikal. What archaeologists didn't know was that literally within walking distance of Tikal, surrounding that whole area were more than 60,000 structures that they hadn't identified. And these have all been identified by LiDAR in a country that's just 100,000 kilometers in area. So how did they feed all these people? The answer was they invented a soil. And that soil has a name. It's called terra preta. Archaeologists refer to it as Amazonian dark earths or Amazonian black earth. It's a man-made soil. It's thousands of years old. It's full of microbes that are not found in adjoining soil. It's based around biochar. And you can take a handful of 8,000-year-old terra preta and you can add it to barren soil, and that soil will instantly become fertile. It's highly sought after in the Amazon, and it explains how they fed these people. There was science in the Amazon.
How did they create this?
Well, this is something that's not understood. It's still not understood by soil experts to this day as to how that was done, but it's one of many intriguing pieces of evidence of much higher development in the Amazon that it has been given credit for, and of a kind of science in the Amazon. Secondly, new evidence previously not recognized. The Amazon is basically a garden. The Amazon is a man-made rainforest. There are certain trees like Brazil nut trees or the ice cream bean tree, which are food crops, which are very, very valuable, and they dominate the tree regime in the Amazon. They're what's referred to as hyperdominant species. In other words, people living in the Amazon over thousands of years selected certain trees, which they then cultivated and grew. So the whole thing is not simply a wild, pristine rainforest. It's a very ancient man-made environment. And emerging from that man-made environment, as well as evidence of large cities, large populations, and this mysterious dark earth, are huge geometrical structures.
What are the dates?
The earliest dates that have been found in these sites now are about 3,500 years old. About 3,500 years old. But the evidence is that the sites have been constantly remade. And what intrigues me is what remains in that 5.5 million square kilometers that has not been investigated yet. We are just, I think, looking at the edges of a mystery. The archaeologists involved, who are mainly from Finland and also from Brazil, feel the same. Their estimate is that there are thousands of these structures remaining in the jungle, and they're open as to how old they may ultimately prove to be. The investigation needs to be done. But what's fascinating about them is this very powerful geometry and astronomy. So a number of the sites are perfectly aligned to true north, true south, true east, and true west. I'm not talking about magnetic north. I'm talking about true astronomical north. To do that, there's only one way to do it, and that's with astronomy. So that tells us that astronomers were at work in the Amazon. The geometry is very complex and very precise. That tells us that people with geometrical skills were at work in the Amazon. And thirdly, the scale of the sites of hundreds of meters, gigantic earthworks on the scale of hundreds of meters, tells us that this was highly organized project that was undertaken on a very large scale by very large numbers of people. For example, evidence that large cities flourished in the Amazon. Enormous cities, which were larger than there was a Spanish explorer who went down the Amazon River system in 1541 to 1542. He was the first European to cross the entire length of South America from west to east along the Amazon. He reported seeing incredible cities, advanced arts and crafts, millions of people, a thriving culture. And 100 years later, when other Europeans got into the Amazon, they couldn't find these cities. So they said, oh, Francisco Orellana, that was his name, made it all up. It was just a fantasy. And then in the last decade, as the clearances of the Amazon have proceeded, we've begun to see the traces of those cities. What happened was that the Spaniards brought smallpox into the Amazon. Oh. Smallpox devastated the local population because there was no immunity to it. There was a massive die-off. The cities were deserted. Within 50 years, they were completely overgrown by the jungle, and that's why they were not seen by the explorers who came in 100 years later.
And of course, it's a deep question, important one, but how could we ever possibly know?
I mean, this is another very hard problem about how we test for consciousness in things that are not ours. I mean, we face this even with other human beings. I mean, it's often said that I only know for sure that I'm conscious. It's just an inference that you are, and that any of you are. But it's a reasonably safe inference.
You were wondering.
But you would say that. You would say that. It's a pretty safe inference, Dave.
Me too.
Not so sure. But because we have so much else in common, right, we can basically say it would be very strange if it was only me that was conscious, given everything else that we have in common. The further we get away from the benchmark of an intact human being, the harder it gets, even with human patients suffering brain injury.
Of course,
it's already very difficult to know whether they're conscious, because whether they are or not can be dissociated from their behavior, their ability to tell you that they're conscious. And then the further we get, we have huge debates about non-human animals. There was a recent New York declaration about animal consciousness, trying to just put the idea in people's minds that many non-human animals might be conscious.
Vegan, just saying.
I like the thought experiment. I mean, this thought experiment has been used for many different purposes, but I think one thing it does wonderfully is it illustrates the gap, a certain kind of gap between our understanding of the objective world and our understanding of consciousness. Because you can set it up so that Mary seems to know all of the objective properties of the brain, how your eyes respond to different wavelengths, and how it gets fed to visual cortex, how it gets categorized, how it is we come up with labels like red, green, blue, and so on. She knows all that before she ever sees color. So you'd think she knows everything about the world, but she knows everything about the objective world, but she doesn't know about the subjective experience of seeing red. If she sees it for the first time, it's like, oh, so that's what it's like to see red. Now, Jackson goes on to argue from here that this shows there's more in the world than physical processes, and that's a further story that involves a lot of controversial elements. But I think it's a wonderful illustration of this basic gap between our knowledge of the objective world and our knowledge of subjective experience.
Many non-human animals will be conscious in different ways. And I do think consciousness is very likely something that's a material phenomenon. So it's very plausible to me that it could be implemented in something else, but maybe not in computers. Another example where I worry about a lot more than GPT-5 suddenly really feeling things are emerging neurotechnologies, things like brain organoids. These are collections of human brain cells grown from stem cells in dishes. And they don't exercise any of our biases because they don't do anything. They just kind of sit there in a dish. But they're made out of the same stuff, and they self-organize, and they display electrical activity. So immediately a whole area of uncertainty goes away. Frankly, we don't know whether it matters what we're made out of. And we just don't know whether it matters or not. It's just, I put it in a particular way. It's the idea of the brain as a prediction machine. So arguably, it's not really a theory of consciousness at all, because it does not say, like, these are the sufficient conditions, and then boom, consciousness happens. The other theories tend to say something like this.
Yes.
The idea of the brain as a prediction machine goes way back, and it's really this idea that everything the brain does, pretty much, involves it making predictions about the causes of sensory signals, and then using sensory signals to calibrate, to update these predictions. The sort of slogan for this is that perceptual experience is a kind of controlled hallucination. That we don't read the world out objectively, we
create
kind of
it.
actively construct it.
Right.
But then the way I take it is that doesn't just apply to the world around us. It applies to the experience of being a self within that world. It applies to emotion. It applies to free will. And ultimately, it's all about physiological regulation of the body. The reason brains do this prediction is because prediction allows control, and brains evolved, I think, fundamentally to control, regulate, keep the body alive.
Maybe we shouldn't. If you ask me, what do you mean by the mass of a particle? I'd actually tell you functionally what the mass does, how it responds to gravity, how it responds to forces. If you said to me, what do you mean by the electric charge of a particle? I'd kind of play the same game. I'd say, well, in an electric field, it will do this or that based upon the charge it has. But I would be unable to tell you what mass is and what charge is. They're primitive fundamentals that exist in the universe, and I'm willing to say, okay, they exist by fiat. I know they're there and go forward. Could it be that one day we simply say, consciousness, it's just this fundamental quality of reality, and it doesn't have a deeper explanation, and you take it as a given and you go forward?
This is great because the Norwegian philosopher Hedda Hasselmørch has called this the hard problem of matter.
Do you, David, think that an artificial system will ever be conscious?
I think it's possible for an AI system to be conscious. I think it's possible for a machine to be conscious. The brain itself is a big machine. Somehow that machine produces consciousness. We don't know how, but it does it somehow. And I think if biology can do it, I don't see why silicon can't do it. We don't understand how silicon could give us consciousness. We also understand how neurons could give us consciousness. So I don't see a difference in principle.
So that's a yes.
That's a yes.
I take it. Absolutely. And Neil, how about you?
I'm going to give the annoying "it depends" answer. It depends on what we mean by AI. So I think for the kinds of AI that we have at the moment, I think it's very, very unlikely.
Wherever it happens, should we be thinking about the ethical, moral side of this? I mean, if there's this conscious being that maybe can't even communicate its conscious state, do we worry about that?
I think absolutely. I mean, consciousness, many people think, including me, consciousness is kind of the gateway to the circle of morality, the circle of beings that we care about. The moment you acknowledge that there's a debate about whether fish, let's say, are conscious, but the moment you acknowledge that a fish is conscious and can feel pain and suffer, then suddenly a fish is a being that we should at least take into consideration in our moral calculus. If you don't take conscious beings into consideration, there's the danger of moral catastrophe. So I think this very much applies to AI and even to the emerging systems like the large language models of the GPT family. We don't know for sure whether they're conscious. There's various reasons for thinking there's potential obstacles to consciousness they haven't overcome yet. But I think it's entirely possible that in the next 10 years or so, we will develop language models that overcome those obstacles and show every sign of being conscious. We've already got language models which are very close to passing the traditional Turing test, being indistinguishable from human beings in conversation. Some personas generated by GPT-4 have passed 5-minute Turing tests. In the past, we would have said that's evidence of consciousness. Now, maybe it's not. Maybe for various reasons, we want to resist that. All I want to say, that question, though, is all important, because if an AI system is conscious like a human, and we continue to treat it simply like a tool, so that we don't even have to take it into account in what we do, we are in danger of moral catastrophe.
Imagine that in the far, far future, there's a brilliant neuroscientist named Mary, who, for some reason, is confined to a room in which everything appears in black and white. There is no color of any sort whatsoever. Mary can study and access and examine the world outside, but it all comes to her only in black and white. Even so, Mary is able to reach a goal that has long eluded humankind. She totally and fully unravels every last detail about the structure, function, physiology, chemistry, biology, and physics of the brain. She knows absolutely everything there is to know about the behavior of the brain's every neuron, every molecule, every atom. She knows precisely what goes on inside our heads, the details of all neural processes that cascade when we see a beautiful red rose, or when we marvel at a rich blue sky. One day, Mary is allowed to leave her room, and the very first thing she sees is a plump red tomato. Now here's the question. From this experience of the color red, will Mary learn anything new? Will she shrug and just move on? Or will she be surprised or thrilled or moved or gain some new insight through this actual experience of color? And if she does, what does that tell us about the limits of a purely physical description of the brain and consciousness?
So that's the little story. So what should we take from, and where do you come down on that story?
And it gets to it right away.
This is the dumbest it will ever be.
Yeah, that's what's crazy. That's what's crazy. So imagine something like that, but even more advanced, multiple stages of improvement and innovation forward, and then it interfaces directly with the mind, but it only does it with the people that can afford it.
Yeah.
And those people are just regular humans. So they haven't been enhanced. We haven't evolved physically. We still have all the human reward systems in place. We're still basically these territorial primates. And now We have, you know, you just imagine some fucking psychotic billionaire who now gets this implant and decides to just completely hijack our financial systems, acquire all the resources, set into place regulations and influences that only benefit them, and then make sure that they can control it from there on. It's the best. It's the best, but it's also has the most problems, the most social problems, the most awareness of social, environmental, infrastructure, the issues
we get
that
to
we
go.
have.
We get to go solve them.
Yeah.
And I, intuitively, I think I feel something somewhat different than you, which is I think humans in something close to this form are going to be around for a lot longer than, I don't think we're the last humans.
How long do you think we have?
Like longer than a time frame I can reason about.
Really?
Now, there may be like, I could totally imagine a world where some people decide to merge and go off exploring the universe with AI, and there's a big universe out there. The thing that I find myself most interested in is what we can do without drilling a hole in someone's head. How much of the inner monologue can we read out with an externally mounted device? And if we have a imperfect, low bandwidth, low accuracy neural interface, can people still just learn how to use it really well in a way that's like quite powerful for what they can now do with a new computing platform? And my guess is we'll figure that out.
I'm sure you've seen that headpiece. There's a demonstration where there's someone asking someone a question. They have this headpiece on, they think the question, and then they literally Google the question and get the answers through their head. Well, it certainly seems like that is the greatest potential, greatest positive potential of AI. It is to solve a lot of the problems that human beings have had forever, a lot of the societal problems that seem to be, I mean, that's what I was talking about an AI president. I'm kind of not joking, because I feel like if something was hyper intelligent and aware of all the variables with no human bias and no incentives, no other than here's your program, the greater good for the community of the United States and the greater good for that community as it interacts with the rest of the world. The elimination of these dictators, these whether they're elected or non-elected, who impose their will on the population because they have a vested interest in protecting special interest groups and industry.
I think as long as the thing that I find scary when you say that is it does.
You want to know a wild one? From the implementation from Orville and Wilbur Wright flying the plane, it was less than 50 years before someone dropped an atomic bomb out of it.
That's wild.
That's fucking crazy. That's crazy.
Less than 40, right? That's crazy.
Yeah. Bananas. I mean,
60-something years to land on the moon.
Nuts. Nuts. Where is it going? I mean, it's just guesswork.
And my view of the world now, sort of looking backwards and forwards, is that this is like one long technological revolution. And we had, like first we had to figure out agriculture so that we had the resources and time to figure out how to build machines. And then we got this industrial revolution, and that made us learn about a lot of stuff, a lot of other scientific discovery too. Let us do the computer revolution, and that's now letting us, as we scale up to these massive systems, do the AI revolution. But it really is just one long story of humans discovering science and technology and co-evolving with it. And I think it's the most exciting story of all time. I think it's how we get to this world of abundance. One of the things that I've observed, obviously many other people too, is corruption is such an incredible hindrance to getting anything done in a society to make it forward progress. And my worldview had been more U.S.-centric when I was younger, and as I've just studied the world more and had to work in more places in the world, like it's amazing how much corruption there still is. But the shift to a technologically enabled world, I think, is a major force against it because it's harder to hide stuff. And I do think corruption in the world will keep trending down.
because of its exposure
Yeah.
through technology. It's a very natural way to talk. I wonder if through the implementation of technology, if it becomes even more immersive than a one-on-one conversation, even more interactive, and you will understand even more about the way a person feels about what you say, about that person's memory, that person's life, that person's history, their education, how it comes out of their mind, how their mind interacts with your mind, and you see them. You really see them. I wonder if what we're experiencing now is just like the first time people invented guns, they just started shooting at things, you know?
Yeah. If you can like feel what I feel when you say something mean to me or nice to me,
Right.
like that's clearly going to change what you decide to say.
Yeah. If it keeps going, it has to go to some impossible level of capability. I mean, just think of
That
I
believe is going to happen.
What we're able to do now with nuclear power and nuclear bombs and hypersonic missiles and just the insane physical things that we've been able to take out of the human creativity and imagination, and through engineering and technology implement these physical devices that are indistinguishable from magic if you brought them 500 years ago.
Yeah. I think it's quite remarkable. It, like,
so
makes
keep going 100,000 years from now. If we're still here, if something like us is still here, what can it do? If you're microwaving food, you're fucking getting it. You're just getting it. If you eat processed food, you're getting it. You're getting a certain amount of microplastics in your diet, and estimates have been that it's as high as a credit card of microplastics
like
per
floating
week
around
in your body. You consume a credit card of that a week.
Whoa.
The real concern is with mammals, because the introductions, when they've done studies with mammals, when they've introduced phthalates into their body, there's a correlating one thing that happens is these animals, their taints shrink. Like the taint the mammal, when you look at males, it's 50% to 100% larger than the females. But with the introduction of phthalates on the males, the taints start shrinking, the penises shrink, the testicles shrink, sperm count shrinks. So we know there's a direct biological connection between...
There's something about the phrase, do the greater good for humanity.
I know, it's terrifying. It's very Orwellian. All of it is. But also, so is artificial general intelligence.
For sure.
Open the door,
I
Hal.
wish I had worked on, something that was less morally fraught.
But do you? Because it's really exciting.
I cannot imagine a cooler thing to work on. I feel unbelievably... I feel like the luckiest person on earth.
That's awesome.
It is not... It's not on easy mode. Let's say that.
Oh, yeah.
This is not life on easy mode.
No. I mean, you are at the forefront of one of the most spectacular changes in human history. And I would say more spectacular than the implementation of the internet. I think the implementation of the internet was the first baby steps of this, and that artificial general intelligence is...
Yeah.
It is the internet on steroids. It's the internet in hyperspace.
What I would say is it's the next step, and there will be more steps after.
Yes.
But it's our most exciting step yet.
Yeah. My wonder is, what are those next steps after?
Isn't that so exciting to think about?
It's very exciting. That seems inevitable. Those two things seem inevitable to me. The inevitable thing to me is that we will create a life form that is an artificial, intelligent life form that's far more advanced than us, and once it becomes sentient, it will be able to create a far better version of itself. And then as it has better versions of itself, it will keep going, and if it keeps going, it will reach godlike capabilities. The complete understanding of every aspect of the universe and the structure of it itself, how to manipulate it, how to travel through it, how to communicate. And that, if we keep going, if we survive 100 years, 1,000 years, 10,000 years, and we're still on this same technological exponential increasing in capability path, that's God. UBI. What they're really concerned with is human nature. right? They believe that if you remove incentives, if you just give people free money, they become addicted to it, they become lazy. But isn't that a human biological and psychological bottleneck? And perhaps with the implementation of artificial intelligence combined with some sort of neural interface, whether it's external or internal, it seems like that's a problem that can be solved, that you can essentially, and this is where it gets really spooky, you can re-engineer the human biological system, and you can remove all of these problems that people have that are essentially problems that date back to human reward systems when we were tribal people, hunter-gatherer people, whether it's jealousy, lust, envy, all these variables that come into play when you're dealing with money and status and social status. If those are eliminated with technology, and essentially we become a next version of what the human species is possible. Yeah. I think so too, and my concern is that the initial adopters of this will have such a massive advantage over the general population.
Well, that doesn't concern me because that's like a, that's just like better, that's a better computer. You're not like jacking your brain into something in a high-risk thing. You know what you do when you don't want them? When you take off the glasses.
Mm-hmm.
So that feels fine.
Well, this is just the external device then.
Oh, I think we can do the kind of like read your thoughts with an external device at some point. Read your internal monologue.
Interesting. And do you think we'll be able to communicate with an external device as well, telepathically, or semi-telepathically through technology?
I do.
Yeah.
Yeah, I do.
I think so too. My real concern is that once we take the step to use an actual neural interface, when there's an actual operation and they're using some sort of an implant, and then that implant becomes more sophisticated. It's not the iPhone 1, now it's the iPhone 15. And as these things get better and better, we're on the road to cyborgs. We're on the road to, like, why would you want to be a biological person?
The platform to be accepted for the ideas is not social media. It is not Joe Rogan. It is not my podcast. It is research journals where attention can be given on a level that at the end of the day offers no higher respect for your energy and intellect than by declaring that what's in it is either right or wrong or worthy of publication or not. I'm going to read you just my opening line here. It's titled 1 × 1 = 2. So I lead off by saying, this is an ambitious work that is a clear indication of a restless, active mind. Within these pages, however, there are many assumptions and statements that are underinformed, misinformed, or simply false, thereby compromising or nullifying many of the subsequent conclusions you have drawn. That's exactly what should happen in a peer review, out of respect for one another's intellect. It opens with a quote from Terence. It can never occur that the square root of a given number, when added to itself, is greater than the initial number squared, for that would expose a loose thread within the fabric of our understanding, a loose thread capable of unraveling the very ground rules of mathematics. That's a bold statement. So then I just say, this opening thesis is false. I recently learned I got name-checked by Terrence Howard on his recent appearance on Joe Rogan.
I reached out to Neil deGrasse Tyson. He was like, hey man, yeah, I'd love for you to come on my show, do my radio, do my TV thing. Would love that. I was like, yeah, but I've got something I want to introduce to you.
I got name-checked because 8 years ago, he sent me a 36-page treatise.
And it was only 36 pages.
So this is Terrence Howard attempting to reinvent mathematics and physics. A little backstory there. I took initial interest in Terrence because my mother said to me, do you know Terrence Howard? Science is about reproducibility. I can have the most brilliant, crazy, fun idea ever, and if I perform an experiment and no one else can duplicate that experiment, it belongs in the trash heap. It's me in my own world, thinking I have landed on an objective truth, when in fact I haven't. That's how science works, the reproducibility of results. As for the work of Tesla, much of it had very real value to physics and our understanding of electromagnetism. And that value is duly recognized by my community in the naming of a unit of electromagnetism after him.
That's if there's not a multiverse.
Yeah, we need a multiverse.
And if the theory that each galaxy, which contains a supermassive black hole, that inside that supermassive black hole, if you could somehow get through the event horizon, you will go to another universe that has hundreds of billions, if not trillions, of galaxies as well. And that is the portal, and this is the process that they all have, that there is just an infinite number of universes. It is possible, right?
Right, but as I mentioned before, the plausible accounts that have been, to render the multiverse concept plausible, one needs a universe-generating mechanism. And
which also means something intelligent.
It means something some prior fine-tuning.
But that could be also the case, right?
Right.
This universal intelligent thing is
I'm not against the multiverse.
It infinite number of universes.
It might be true, it might be false, but it's only plausible if there's prior design.
Take the extreme case of this. Like imagine if we, 1,000 years from now, have built our own planetary-sized computer that can run these simulations, and we are just about to switch it on, and it will create a simulation of precisely people like ourselves. And as we move towards the big button to sort of initiate this, then the probability of the first two hypotheses basically goes to zero.
Right.
And then we would have to conclude with near certainty that we are ourselves in a simulation as we push this button to create a million simulations.
Once we achieve that state, but we have not achieved that state, why would we not assume that we are in the actual state that we currently experience? I don't think he's disagreeing with you with that. I think he's disagreeing the term
you're
that you're using.
a reserved term of art. Okay. And you're using it incorrectly.
That's what he's saying.
And you're going to pay a penalty.
Okay, I don't want to pay no penalties.
Like this is a thing where, like, if I'm watching an MMA fight and someone's doing commentary and they call a kick wrong, I'm like, why are you doing this? You don't even know what that is. Like you incorrectly reference something that's very specific that we've been talking about for a long time.
If you're if you're getting intimate with your lady and you're into rough play and she's not wearing any clothes, is it a rear naked choke if she grabs you from behind? No.
Oh, I'm sorry.
No, it's not a question.
No, it's not.
Of that.
I don't think he's saying this is a negative.
No. I didn't see it as a negative. But
what I'm trying to say is, if the reason that science works as well as it does is that up until very recently, there were clear rules, cultures. We agreed to leave certain things that are at the door, like our religious beliefs. We agreed to submit to certain sorts of things. We were decent to each other. And that system is in a process of collapse at the moment. All right? Now,
the answer you give is the following. When you look to see, did the electron go through one slit or the other, you, or whatever video camera you had or whatever, becomes entangled with the electron. And what that means is that the wave function of the whole universe, the wave function of both the electron but also your camera and you and the stars and galaxies and so forth, splits in two. And there's now one branch of the wave function which acts like its own separate world, which says the electron went through the left slit and your camera saw it go through the left slit and it made a little line on the other side. And there's another branch which says the electron went through the right slit and your camera saw it go through the right slit and it makes a line on the other side. And so they're both still there, but the world's split in two and now you're only in one of them. The electron is acting like a wave, and when you look at it, the electron acts like a particle.
Right.
That is the lesson of the double slit experiment.
Right. Why?
Yep. Why? Because when you put that detector on the slits, you interacted with the electron and you localized it, right? There was no such thing as the position of the electron. There was no such thing as the answer to the question, did it go through one slit or the other? There was only a cloud. There was only a wave going through. But you affected it, or whatever the detector was, affected it when it looked through the slits to see, did it go through this one or this one? And that effect changed it from being going through both slits to being only going through one.
Let's explore self-replicating machines. These are devices capable of making copies of themselves using raw materials from their environment. This concept, inspired by biological systems, could revolutionize manufacturing and space exploration. Imagine machines that build infrastructure on other planets using local resources, reducing the need for supplies from Earth. Self-replicating robots could also help with large-scale environmental projects, like cleaning up pollution or restoring ecosystems. While still largely theoretical, advancements in robotics and nanotechnology are bringing this idea closer to reality. Self-replicating machines represent a fascinating step towards autonomous, scalable technologies. Stay curious. Let's explore cryonics. Cryonics is the practice of preserving individuals at extremely low temperatures after death, with the hope that future medical advancements can revive and cure them. The process involves cooling the body to minus 196 degrees Celsius, minus 321 degrees Fahrenheit, to prevent tissue decay. While cryonics is based on speculative science, it raises fascinating questions about life, death, and the future of medicine. Currently, no one has been successfully revived from cryonic preservation, but ongoing research in fields like nanotechnology and regenerative medicine keeps the possibility alive. It's a controversial yet intriguing glimpse into potential future technologies. Stay curious. Let's discuss the recent CrowdStrike incident and its implications. A massive IT outage caused by a faulty CrowdStrike update led to the infamous blue screen of death, BSOD, for Windows systems worldwide. This impacted airports, banks, hospitals, emergency services, and more, causing significant disruptions. CrowdStrike, a top cybersecurity firm, provides protection and response services to major clients like AWS, Microsoft, and Visa. The incident wasn't a cyber attack, but highlighted the risks of relying on technology for critical infrastructure. It underscores the need for rigorous testing and backup plans to avoid such widespread chaos. Stay cautious. Let's discuss the dangers of relying on technology for banking and medicine. While technology offers convenience and efficiency, it also presents risks. Cyber attacks can compromise sensitive financial and medical data, leading to identity theft, financial loss, and breaches of patient confidentiality. Hacks can disrupt critical systems, causing chaos in banking transactions and medical treatments. Additionally, data loss from system failures or breaches can have severe consequences, such as losing access to important health records or funds. It's crucial to invest in robust cybersecurity measures and backup systems to protect against these threats. Balancing technology's benefits with its risks is essential. Stay cautious. Let's reflect on human progress compared to the age of the universe. The universe is around 13.8 billion years old, but modern humans have only been around for about 200,000 years, a mere blink of an eye in cosmic time. In the last few thousand years, we've gone from basic tool-making to advanced civilizations. In just the last few centuries, we've harnessed electricity, mastered flight, explored space, and created the internet. This rapid advancement in such a short time showcases human ingenuity and our ability to understand and shape our world. It's awe-inspiring to think about what the future might hold. Stay curious. Let's explore quantum computers. Unlike classical computers that use bits as 0s or 1s, quantum computers use qubits, which can be both 0 and 1 simultaneously thanks to superposition. This allows them to process vast amounts of data at once. Quantum entanglement further boosts their power as qubits become interconnected, sharing information instantaneously. These properties enable quantum computers to solve complex problems, like factoring large numbers or simulating molecular structures much faster than classical computers. Although still in early stages, quantum computing holds the potential to revolutionize fields like cryptography, medicine, and artificial intelligence. Stay curious. Let's explore the faint young sun paradox. This paradox arises from the fact that billions of years ago, the sun was significantly fainter, about 30% less luminous than today. Despite this, geological evidence shows that early Earth had liquid water and a warm climate. According to models, the faint young sun should have left Earth frozen. Scientists propose that greenhouse gases like carbon dioxide and methane were much higher, trapping more heat and keeping the planet warm. Solving this paradox helps us understand Earth's early climate and the conditions that allowed life to develop. Stay curious. Let's talk about baryon asymmetry. This term refers to the imbalance between matter and antimatter in the universe. According to the Big Bang Theory, equal amounts of matter and antimatter should have been created. However, we observe a universe dominated by matter, with very little antimatter. This mystery suggests that during the early universe, certain processes led to a slight excess of matter over antimatter. Understanding baryon asymmetry involves studying fundamental particle interactions and the laws of physics. Solving this puzzle could reveal deep insights into the origins and evolution of the universe. Stay curious. Let's dive into quantum foam. Quantum foam, also known as space-time foam, is a concept in quantum mechanics that describes the fabric of the universe at the smallest scales. At this incredibly tiny level, around the Planck scale, space-time isn't smooth, but is instead made up of constantly fluctuating energy and particles popping in and out of existence. This foam is a seething, dynamic structure that influences the behavior of particles and forces. Understanding quantum foam is crucial for unifying quantum mechanics with general relativity and exploring the true nature of space-time. It's a mind-bending glimpse into the universe's foundation. Stay curious. Let's explore epigenetics. Epigenetics studies how gene expression is regulated without changing the DNA sequence itself. Chemical tags, like methyl groups, can attach to DNA or histone proteins, turning genes on or off. These modifications can be influenced by environmental factors such as diet, stress, and toxins, and can even be passed down to future generations. Epigenetics explains how identical twins can develop different traits and why certain diseases may occur. It reveals the dynamic interaction between our genes and the environment, offering new insights into health, development, and evolution. Stay curious. Let's dive into neutrino oscillation. Neutrinos are tiny, nearly massless particles that rarely interact with matter. There are three types: electron, muon, and tau neutrinos. Neutrino oscillation is the phenomenon where these neutrinos switch types as they travel through space. This discovery was surprising because it implies that neutrinos have mass, challenging the standard model of particle physics. Understanding neutrino oscillation helps us explore fundamental questions about the universe's structure and evolution. This mysterious behavior of neutrinos offers insights into the workings of the cosmos at the most fundamental level. Stay curious. Let's talk about the uncertainty principle. Proposed by Werner Heisenberg, this principle states that you cannot simultaneously know both the exact position and momentum of a particle. The more precisely you measure one, the less precisely you can know the other. This isn't due to limitations in measurement, but a fundamental property of quantum systems. It highlights the intrinsic unpredictability of the quantum world. The uncertainty principle is crucial in quantum mechanics, affecting how we understand particles at the smallest scales and shaping technologies like electron microscopes. It challenges our classical view of reality and emphasizes the probabilistic nature of the quantum realm. Stay curious. Let's explore quantum tunneling. This phenomenon occurs when particles pass through barriers that, according to classical physics, they shouldn't be able to cross. Imagine a ball rolling uphill and over a wall without enough energy to climb it. Quantum tunneling is like the ball appearing on the other side. This happens because particles, like electrons, can behave as waves and have a probability of being found on the other side of the barrier. Quantum tunneling is crucial in many processes, such as nuclear fusion in stars and modern technologies like semiconductors and tunnel diodes. It's a fascinating example of quantum mechanics defying our everyday expectations. Stay curious. Let's dive into CRISPR-Cas9. This revolutionary gene editing technology allows scientists to precisely modify DNA. CRISPR stands for Clustered Regularly Interspaced Short Palindromic Repeats, which are sequences in bacterial DNA that remember viral invaders. Cas9 is an enzyme that can cut DNA at specific locations. By guiding Cas9 to a targeted gene sequence, scientists can add, remove, or alter genetic material. This has enormous potential for curing genetic diseases, improving crops, and advancing biological research. However, it also raises ethical questions about the extent of genetic modifications. CRISPR-Cas9 represents a monumental leap in genetic science. Stay curious. Let's explore the black hole information paradox. This paradox arises from the clash between quantum mechanics and general relativity. When an object falls into a black hole, its information seems to disappear, violating quantum theory's principle that information cannot be destroyed. Stephen Hawking proposed that black holes emit radiation known as Hawking radiation, causing them to evaporate over time. But what happens to the information? Is it lost forever, or somehow encoded in the radiation? This paradox challenges our understanding of physics and suggests that new theories may be needed to reconcile these fundamental principles. Stay curious. Let's dive into the Kardashev scale. Proposed by astrophysicist Nikolai Kardashev, this scale measures a civilization's technological advancement based on energy consumption. There are 3 types. Type 1 harnesses all the energy available on its home planet. Type 2 captures all the energy from its star, like a Dyson sphere, and Type 3 utilizes energy on a galactic scale. Currently, humanity is around Type 0, using a fraction of our planet's energy. Advancing on this scale represents significant leaps in technology and energy management, offering a fascinating glimpse into the future of civilization. Stay curious. Let's explore the anthropic principle. This idea suggests that the universe's physical constants are fine-tuned to allow the existence of life. There are 2 main versions. The weak anthropic principle states that we observe the universe's conditions because we are here to observe them. The strong anthropic principle goes further, suggesting the universe must have properties that allow life to develop at some stage. This principle helps explain why the universe seems perfectly suited for life, but it's also debated as it touches on philosophical questions about our place in the cosmos. Stay curious. Let's dive into the Alcubierre warp drive. Proposed by physicist Miguel Alcubierre, this theoretical concept suggests faster-than-light travel is possible. The idea involves creating a warp bubble that contracts space in front of a spacecraft and expands it behind, effectively moving the ship faster than light without violating the laws of physics. This is based on Einstein's equations of general relativity. While the energy requirements are currently beyond our reach, the concept opens exciting possibilities for interstellar travel. The Alcubierre warp drive remains a fascinating idea that pushes the boundaries of our imagination and science. Stay curious. Let's explore the holographic universe. This theory suggests our universe might be a giant hologram. It proposes that all the information in our 3D universe is encoded on a 2D surface, much like a hologram on a credit card. This idea stems from black hole physics, where information about all objects that fall in is thought to be stored on the event horizon, a 2D surface. If true, it could resolve paradoxes in quantum mechanics and gravity. Offering a unified theory of the universe, it's a mind-bending concept that challenges our perception of reality. Stay curious. Let's explore how AI could revolutionize physics. AI can analyze vast amounts of data much faster than humans, uncovering patterns and insights that were previously hidden. In physics, this means accelerating discoveries in areas like quantum mechanics, astrophysics, and particle physics. AI algorithms can simulate complex systems, predict outcomes, and optimize experiments, saving researchers time and resources. For instance, AI has already helped detect gravitational waves and identify new exoplanets. As AI continues to evolve, it holds the potential to unlock new laws of physics and transform our understanding of the universe. Stay curious. Let's explore the Fermi paradox. Named after physicist Enrico Fermi, it questions why we haven't found evidence of extraterrestrial life despite the vastness of the universe. There are billions of stars and potentially habitable planets, so where is everyone? The paradox suggests several possibilities. Advanced civilizations might be rare, they could be avoiding us, or maybe they're extinct. It also raises the idea that we might not recognize signs of alien life due to different technologies or forms of communication. The Fermi paradox challenges our understanding of life in the universe and keeps us searching for answers. Stay curious. Let's talk about Schrödinger's cat. This thought experiment by physicist Erwin Schrödinger illustrates quantum mechanics' strange nature. Imagine a cat in a sealed box with a radioactive atom, a Geiger counter, and poison. If the atom decays, the Geiger counter triggers the release of poison, killing the cat. According to quantum mechanics, until we open the box and observe, the cat is both alive and dead simultaneously, existing in a superposition of states. This paradox highlights the weirdness of quantum mechanics and the role of observation in determining reality. Stay curious. Let's dive into the double slit experiment. This famous experiment shows how light and particles can behave as both waves and particles. When light passes through two slits, it creates an interference pattern on a screen behind, like waves overlapping. However, when particles like electrons are sent through one at a time, they still create the same pattern, suggesting they act as waves. But here's the twist. If you observe which slit the particle goes through, the pattern changes to two stripes, as if the particles know they're being watched and act like particles. This experiment challenges our understanding of reality and the nature of observation. Stay curious.